So next let's look at 1c, and again we're going to use these key derivatives, and probably just the first one actually. So let's see how we would use it in 1c. I have three terms here. I'm going to call it 1, 2, and 3. And you see that the first term is a product of two terms, so let's take that derivative using the product rule. So with the product rule, I get 1 for the derivative of x, and then the second term stays as is, and then I add up, just x stays as is, and then I have to put down the derivative of arcsine of x the whole square. So what's the derivative of arcsine of x the whole square? Let's use a chain rule there. We get the 2 arcsine x. This is just applying the power rule for derivatives. And then I have to take my derivative of arcsine, which gives me that. Okay, so we're done taking the derivative of the first term. The second term is nice and easy. That derivative is just minus 2. For the third term, again, we have a product of two terms. So product rule again. So the two just hangs out there, that constant 2. And then I take the derivative of the square root 1 minus x squared. Because of the power rule, I get a half times 1 over 1 minus x squared. This is just the power rule for derivatives. And then I have to multiply by the derivative of 1 minus x squared, which is just minus 2x. So there was a chain rule there and a power rule, or a couple of power rules even. So that's the derivative of that square root term, so the square root of 1 minus x squared. The arcsine stays as is, and then product rule in the second term, the square root 1 minus x squared and the 2 stays as is. And then we take the derivative of arcsine, which is just 1 over 1 minus x squared. And this seems like a monstrous problem, but a lot of simplification happens. So, for instance, you see that in this term, some of these 2's cancel out, and we're left with minus 2x arcsine x. But the second term there was plus 2 arcsine x over 1 over the square root of 1 minus x squared. That's a mouthful. And so these two cancel out. The last term here, there's some cancellation as well, so we're just left with plus 2. But we had a minus 2 from one of the derivatives, so that cancels out as well. And so we're just left with arcsine x squared. And we're done.